And now I will introduce you to one very important theorem on differentiation of function. And this theorem, and which is also called as the chain rule, and as per this theorem or by the chain rule, if f of x and g of x are two differentiable functions with respect to x, then their composition function f of g is also differentiable with respect to x, and its differential coefficient or f of g dash x is given by the differential coefficient of f with g of x as argument into the differential coefficient of g with respect to x. Now it will appear some way confusing to you. Now I explain you further. Now suppose we have a function which is defined as z is equal to f of y and y is equal to g of x. Now here you can see we can find we can find differential coefficient of z with respect to y, and here we can find the differential coefficient of y with respect to x. But if we want to find the differential coefficient of z with respect to x, then as per the chain rule, the differential coefficient of z with respect to x is given by differential coefficient of z with respect to y into differential coefficient of y with respect to x. Or in other words, we can also say the derivative of z with respect to x is equal to the derivative of z with respect to y into the derivative of y with respect to x. And also remember, this chain rule can be further extended to more than two functions. And now suppose we have got three functions defined as z is equal to f of u, and similarly u, and the second function is u is equal to g of v, and the third function v is equal to h of x. And now in this case, the derivative of z with respect to x is equal to the derivative of z with respect to u into the derivative of u with respect to v into the derivative of v with respect to x. Or in other words, dz upon dx is equal to dz upon du into du upon dv into dv upon dx. And now to further understand this chain rule, let's find out the differential coefficient of some of the function with the help of chain rule. Now let's solve our first question. Find the differential coefficient of sine of x square plus 1 with respect to x. And here the function y is equal to sine of x square plus 1. And now let's make use of chain rule in this question. Now suppose we put x square plus 1 as equal to another function u. And now putting u as equal to x square plus 1, we have y is equal to sine of u, and u is equal to x square plus 1. So now here we have got two functions, and the first function y is equal to sine of u, and the second function is u is equal to x square plus 1. And now for the first function, let's find the differential coefficient of y with respect to u, or dy upon du. And what's the differential coefficient of sine of u? You know it very well that differential coefficient of sine u is equal to cos of u. So we can write dy upon du is equal to cos of u. And in the second equation we have u is equal to x square plus 1. So, and the differential coefficient of the function u with respect to x, or du upon dx, is equal to, what's the differential coefficient of x square? Of course, it's 2x, and the differential coefficient of 1 is 0. So that means du upon dx is equal to 2x. And as per the chain rule, dy upon dx is equal to dy upon du into du upon dx. And we have already evaluated dy upon du and du upon dx, and now putting these values in this equation. So dy upon dx is equal to cos of u into 2x, or 2x into cos of u, but u is equal to x square plus 1. That means dy upon dx is equal to 2x into cos x square plus 1, or the differential coefficient of the function sine of x square plus 1 with respect to x is equal to 2x into cos x square plus 1. So in this question, we made use of chain rule to find the differential coefficient of the given function. And now let's solve one more question for finding out the differential coefficient of a function with the help of chain rule. And in this question, differentiate log of sine x with respect to x with the help of chain rule. Now suppose y is equal to log of sine x. And now here, if you look carefully at this function, you can see that it is composed of two functions. The first function is log of x, and the second function is sine of x. And if we can put u equal to sine x, then we have y is equal to log of u, where the function u is equal to sine of x. And now let's find the differential coefficient of y with respect to u and the differential coefficient of u with respect to x. And we know it very well that differential coefficient of log of x is equal to 1 upon x. So dy upon du is equal to 1 upon u. And the differential coefficient of sine x is equal to cos of x. So du upon dx is equal to cos x. And now here we have to find out the value of dy upon dx. And as per the chain rule, dy upon dx is equal to dy upon du into du upon dx. And dy upon du is equal to 1 upon u. And du upon dx is equal to cos of x. That means dy upon dx is equal to 1 upon u into cos x. And what's the value of u? In the beginning, we had put u as equal to sin x. So dy upon dx is equal to 1 upon sin x into cos x, or cos x upon sin x, and which is equal to cot of x. So that means the differential coefficient of log of sin x is equal to cot of x.